Hey guys, today we're going to talk about graphing polynomials with multiplicities. And so obviously a polynomial is just any term that has x in it, and then it can have a constant, it can have x cubed, anything like that. And then multiplicity just means how many times a zero occurs. So let's just go over some of the aspects of it. We have a real zero, which is just classified as the x-intercepts of a polynomial. So that's just where the polynomial touches the x-axis. So let me just draw one here really quick, an axis. And if we have something that looks like, I don't know, here, our real zeros would be these points here where it touches the x-axis. So we got one here, and we got one here. So those are our three real zeros. And then, like I said, multiplicity, each zero has a multiplicity associated with it. The zero's multiplicity is the number of times the factor associated with that zero appears in the given polynomial. And the best way to think about this is just to see an example. So we have the polynomial x plus 6 times x minus 5 squared. So if you think about it, our two zeros are found by setting each factor equal to 0. So x plus 6 equals 0 would be negative 6. So negative 6, and then like we said, multiplicity is the number of times the factor with that 0 appears. Well, I just see it once because it's only x plus 6 to the first power. I could write a 1 right here. And so negative 6 has a multiplicity of 1, and 5, which is the factor I get from x minus 5, that's squared, so it has a multiplicity of 2. So multiplicity affects graphing because it determines if a function goes through the x-axis or just bounces off and stays above or below it. So even multiplicities will touch the x-axis and go back in the direction they came, while odd multiplicities will go right through the x-axis. And that's the important part. So I'm just going to graph based on a sign chart actually, so let me draw a little sign chart here. We can get the general shape of this polynomial x plus 6 times x minus 5 squared. First step is to write our two zeros in. So we figured out they were negative 6, and we figured out it was positive 5. And then it says even multiplicities will touch the x-axis and go back in the direction they came. So I know that at the point 5, which has an even multiplicity of 2, that if it starts on the top, it's just going to stay on the top and bounce up. But it could start on the bottom, and then it's going to stay on the bottom and bounce down. So that's what it says when it's an even multiplicity. Then for an odd multiplicity, it says it's just going to go through the x-axis. So if it's starting out below, it's going to go straight through when it touches that negative 6. And when it's starting out above, it's going to go straight down when it touches the negative 6. So that's how we can tell where it's going to go based on multiplicity. But we see a problem here. How do we know where it starts? How do we know if it's going to start by going up or start by going down? That's when we need to think back to in behavior. So in behavior, remember there were like 4 rules. The 4 rules were if it's a positive even, it does something. If it's a positive odd, it does something. And then if it's a negative even or a negative odd, it does something else. So if you think back, try to remember those. I have them listed right here. We'll take a look. So positive even means up, up, so that means it starts up and it ends up. Positive odd, down, up. Negative even, down, down. Negative odd, up, down. So those are our 4 rules. But let's look at this example. So first, let's determine if it's a negative or positive, or not a negative or positive. It's an odd or even degree. Well, we have x plus 6 to the first, then we have x minus 5 squared. So to figure out the total degree, we just need to add those up. So we have 1 on the x plus 6, and we have 2 on the x minus 5. So our total degree is 3, so I'll write that here. We've got degree 3, so we have an odd degree. And the other aspect of it is to determine if it's positive or negative. Well, the x's are positive in both. So x and x stays positive, so the term will be x cubed, which means it's positive. No negatives. So we have a positive odd. And that situation is down, so it's going to start by going down, and then it's going to end by going up. So I'm going to put that on my sign chart right here. So down, up. And now what I need to determine is what happens in between. What happens in here that leads me to end up with this? And that is when we can use our multiplicities. So again, let's put the negative 6. Let's put our 5. And we said, well, negative 6 had an odd multiplicity, so we know it's going to go straight through. So I'm going to have it go straight through the negative 6. And then we said 5 had an even multiplicity, so it's going to bounce. So it's going to bounce right there, and there it is. So that's a sketch of a graph just by giving multiplicities. So we took a complex polynomial and now we know what its graph looks like. That's the beauty of graphing polynomials by multiplicity. So let's look at another example. Give a sketch of the graph x minus 2 squared times x plus 5. This is similar to the one we did. Step 1 is to always just draw a sign chart because we know we're going to have to use that eventually. Let's put our zeros in. So the 0 from x minus 2 is x equals 2. So we know it's going to go through the axis there. And then for x plus 5, we get x equals negative 5. We know it's going to go through the axis there. So I'm going to put negative 5 and positive 2 on my sign chart. Then now I'm going to think, okay, what total degree is this? So again, we have a squared term here, and I have a to the first term here. If nothing's there, I can assume it's the first. So the total degree, I just add them up, 2 plus 1, 3. So again, degree 3. I didn't mean to make this one so similar to the last one, but that's the way it goes sometimes. Alright, so, and then again, we need to think, is it positive or negative? Well, I have positive x here, positive x here, so when I multiply them all out, I will end up with still a positive. So positive degree 3 again, and like we just said, and like I have written to the right hand side, we can see that this is a positive, even odd, so it goes down, starts down, and ends up, going up. And now again, we just need to think what happens. Wow, I really made this exactly like the other one. So it's going to go straight through the negative 5 because that's an odd multiplicity, and it's going to bounce at 2 because it's an even multiplicity. So again, very similar shape to our last graph. Hopefully my next example is a little bit different. Here we go. Alright, so give a sketch of the graph x cubed minus 1. So this one's a little tougher here. X cubed minus 1. So here it says, remember the rational root theorem. So that happened, we talked about that a little bit ago. And that's used to generate a list of possible zeros of a polynomial. And remember that a zero or root is just an x value that can be plugged in and return a value of 0. And the possible zeros are found by listing all the factors of the constant over the factors of the leading coefficient. So let's do that right here. So rational root theorem, I'll just write RRT. It says that the possible zeros will be all the factors of the constant term divided by all the factors of the leading coefficient. So constant term is just negative 1, right? Because that's the constant on the end here. Then the leading coefficient, I'll just write LC for that. That's whatever the coefficient in front of the term with the highest degree is. In this case, the highest degree is obviously x cubed. The coefficient in front, we don't see anything there, so we can assume it's a 1. So constant is negative 1, leading coefficient is 1. Now we need to list all the factors of the constant over the factors of the leading coefficient. So factors of the constant, what factors of negative 1 do we have? Just plus and minus 1. What factors of the leading coefficient do we have? Again, just plus and minus 1. Those are the only two numbers that can go into 1 are 1 and negative 1. So now let's expand this a bit to get some possible zeros. We see that it's 1 and negative 1. No matter how we do these, we could have 1 divided by 1, we could have negative 1 divided by 1, or negative 1 divided by negative 1. We're always going to end up with one of these. So these are our possible roots. Now let's determine which one is a real root, because we need that to then plug into our equation that we have, and then be able to graph what it looks like. So, let's evaluate at f of 1. So that's going to be 1 to the third minus 1. Well, 1 to the third is 1, minus 1 is 0. So that one is a factor. Now let's try f of negative 1. So that says negative equals negative 1 to the power of 3 minus 1 equals, well, negative 1 cubed. Let's be careful here. If it's a negative number raised to an odd power, it equals a negative. So it's going to be a negative 1 minus 1 equals negative 2. So this is not a real root. And the rational root theorem says that all the rational roots will be in this form. Well, if we just have all of them have to be either 1 and negative 1 doesn't work, then the only real root is 1. So that means we can now go answer our question. Draw a sign chart, give a sketch of the graph. So we know the only 0 is going to be positive 1. I'll put that in my sign chart. And then the next step, if you remember, is to find, well, what's it going to do at the end of the graph? So we need to figure out, well, what is the degree? The degree is 3, obviously, and it's a positive. So again, it's positive odd. I should have added a little bit more variety into my questions. positive odd. Then, well, what's the multiplicity of this? X minus 1. Well, we would get x minus 1. Well, I guess it's positive 1, but the multiplicity is just 1, so it's going to go straight through. And positive odd starts down and goes up. So we see that in the end, the graph's just going to look like this. And that's exactly what it looks like. It's just got a little bit of a, little goes in a little bit and then goes out a little bit. But that's fine. For just showing the shape of the graph, this is all you need. So I hope this video was able to help. I hope you can graph polynomials using multiplicities now. Let me know if you have any questions. Thanks for watching.